Hello friends, now we are in the second part of the lecture on extraction of oil from oil seeds, that is the solvent extraction method. So, in this lecture of about half an hour duration, we will study various aspects of solvent extraction of oil. The extraction of oil from oil seeds by means of non-polar solvent is basically a process of solid liquid extraction. The transfer of oil from the solid to the surrounding oil, okay, that is to the surrounding oil solvent solution, which is normally called miscela. It involves three major steps. So, what is we are basically discussing the basic principle of this process. In this prepared oil seed is brought into intimate contact or direct contact with a suitable solvent, a non-polar solvent. Okay. So, what happens? There is the diffusion of the solvent into the solid, which is followed by dissolution of the oil droplets into the solvent, and finally, the diffusion of the oil from the solid particles to the surrounding liquid. So, these three processes actually result into the final recovery of oil, and depending upon how these processes are managed during the extraction process by properly selecting the appropriate parameters during the extraction and during the operation of the machines, etc. So, that will govern these steps, and then finally, the recovery of the oil. Here just see in an overview of the extraction process in a factory, that is the material flow and how the solvent extraction process is carried out is shown. So, the seed in the earlier part of the lecture we saw that the seed is cleaned and dried to suitable moisture content, then it is sent to the decorticating or dehulling, hulls are removed, and then these dehulled materials they may directly be fed to the extraction, all right, to the solvent by pelleting or flaking, or in the pre-press solvent extraction method, the part of that oil is removed by using suitable press, and then this press is sent to the flaking unit or pelletizing unit, and the pelletized these oil seeds or flakes, then they are put into the extraction unit, and this extraction unit may be a continuous belt extraction, horizontal basket extraction, or other different types of extraction which are commonly used in the industry, and we will see these extractors little details of these in the next slides, all right. And then finally, we get oil, that is the miscela, which is a mixture of oil and solvent, and then this miscela is put to the recovery of the oil from the miscela, that is by flashing or by steam stripping and using appropriate distillation method or other methods, that is oil is separated from the solvent, and this solvent is again recycled. On the other hand, the oil meal which is obtained, it also contained approximately 30 to 35% of the solvent. So, this is passed to the desolventizer, where again suitable heat treatment is given to the meal, and then solvent is recovered, recirculated to the again to the extraction unit, and the desolventized meal is toasted or given some heat treatment, and this meal which is obtained depending upon the material. In fact, at present in most of the cases is used for animal feed, but it has a great potential, as we have seen in the earlier class, that is where the texturization of plant protein, where defatted soya meal obtained from the oil milling industries is used for preparation of meat analogs or meat extenders. So, that the defatted meals can be used because it contains very good quality protein depending upon the process used in the extraction and desolventization, pressing, etc. So, this can be used for the preparation of various food products where the protein input is needed. So, they can be used as a protein ingredients in these processes. So, the various factors like physical characteristics of the solid, the characteristics of the solvent, temperature of the extraction processes are in the extractor, all these they influence the solvent extraction process, oil yield and quality of both the oil and meal. So, an open porous structure of the solid material is preferable for the better, and that is maintained by having proper conditions during the flaking or pelletizing operations. Because if it has a good porous structure, it facilitates the diffusion of the solvent into the bed, solid bed, and it also results into better percolation and ultimately the better yield. Solvent which has higher solubility is preferable, and it should have a low boiling point, because the low boiling point makes the separation easier. The rate of extraction can be increased considerably by increasing the temperature in the extractor. Higher temperature means higher solubility of the oil, higher diffusion coefficient and lower micellar viscosity. In fact, a number of processes like cooking, flaking, etc. have been proposed for increasing the porosity of the oil seed before the solvent extraction, because that makes a very important point. Regarding the choice of the solvent, as I told you that the solvent characteristics are very important consideration. So, an ideal solvent for the extraction of oil from oil seed should be having good solubility, that is it should have good solubility of the oil. At the same time, it should have poor solubility for the non-oil components, that is as far as possible only oil should be extracted, other materials should not dissolve in the solvent. The solvent should have high volatility, that is low boiling point, so that the complete removal of the solvent from the miscela and the meal by evaporation is feasible and easy. The boiling point should not be at the same time very low, so that the extraction can be carried out at somewhat high temperature to facilitate the mass transfer. That because the temperature is higher, the mass transfer is better, and the solvent should have low viscosity, so that it should be easy to flow. Also, it should have low latent heat of evaporation, so that less energy is needed for solvent recovery. It should be low specific heat, so that less energy is needed for keeping the solvent and miscela warm. The solvent should be chemically inert to oil and other components of the seed flakes, and it should not be toxic, very important, absolute absence of toxicity and carcinogenicity of the solvent and its residues. It should be non-flammable, non-explosive and non-corrosive, and more importantly its viability or availability. It should be commercially available in large quantities at cheaper rate. That makes very important from the economics point of view. The solvent extraction process has advantage of giving high yield as compared to mechanical expressions, and we can get IL recovery as high as 98-99% in solvent extraction or even more. It spends lower production cost and requires less time. However, there are certain drawbacks of this method as well. The expeller pressed IL is cleaner and more pure. It is higher in natural colors and flavor as compared to the solvent extracted IL. The solvent extraction process requires large volume of solvent, pressure, etc. It needs higher construction cost of the extraction and refining workshops, high maintenance cost, and more importantly the residual IL content in the meal, and that invariably makes this very valuable byproduct of the IL milling industry even non-usable. So, that becomes important factor if the solvent can be completely removed without any reduction in the quality of the meal, so that the meal can be utilized for food purposes, that will give a very good point. So, now let us see you have seen that is the prepared or flagged and porous mass is fed to the solvent extractor, and in which that is it is given that is the conditions of temperature, pressures, etc. are maintained, and there is a direct intimate contact of the prepared mass with the solvent. Solvent flows, penetrate into the mass, the IL dissolves it into, and then it comes out along with the solvent. So, in the batch process you can see here there is a certain quantity of flake is contacted with a certain volume of fresh solvent here, that is the seed is passed, solvent comes, and then it is in the bottom it is provided with certain screen. So, the solvent dissolves and the solvent plus IL, that is the miscela comes, miscela is collected, and then maybe in order to in the batch process also, in order to get better recovery or maximum recovery, this miscela this again refed, and for 2-3 times it is maintained for some time, so to get the maximum IL yield. So, the miscela is finally drained off, distilled, and solvent is recirculated through the extractor until the residual IL content in the batch of flakes is reduced to the desired level. In the continuous type extractors, both the IL seeds and the solvent are fed into the extractor continuously. The different available types of the continuous extractors are characterized by both their geometrical configuration as well as the method by which the solid and solvents are moved, and particularly one in relation to the other. So, most of the continuous extractors which are used, they are either of percolation type or of immersion type. However, that is modern extractors are also available which work on the combination type, which are of the combination type, that is both percolation as well as immersion setup or assembly is provided in the same extractor. So, in the percolation method, the solvent trickles through a thick bed of flakes without filling the void space completely. A film of solvent flows rather rapidly over the surface of the solid particles, and it efficiently removes the IL which has been diffused from the inside to the surface. And this mode of contact is preferable whenever the resistance to diffusion inside the flake is relatively low. For example, in the case of thin flakes with large surface area or open tissue structure, this percolation method is better. In the immersion method, solid particles are totally immersed in a slowly moving continuous phase of solvent. Immersion works better with the materials, offering a greater internal resistance to ion transfer, like in the case of thick particles or where the dense tissue structure is there. The vertical basket or Boltzmann extractor, you can see here in this figure, this extractor consists of baskets, different baskets fixed to an endless chain having descending and ascending leg enclosed in a vapor tight chamber. Each basket is provided with wire mesh bottom, two chambers at the bottom of the vessel are separated by partition plate hold the extract stream. Liquids it percolates along the two legs flows down to these chambers and the solids fed from the vapor tight hopper into the basket at the top. You can see here the solids are fed from here, okay, and it descending leg and a partially enriched solvent, that is a half miscela, that is again sprayed. So, by this the maximum recovery of the oil is ensured. Fresh solvent is sprayed on the top bucket in the ascending length and this percolates and collates in the bottom chamber as half miscela. So, this is how this vertical basket type extractor works. Then immersion type Hildebrand extractor, you can see in this figure, this is a vertical U-shaped total immersion extractor. It consists of screw conveyors with 3 screws each, that is one vertical and another horizontal. So, 3 screws are there and legs in the barrel along with the supporting legs. The helical profile of the screw are perforated to allow flow of the solvent. The solid is fed at the top of the one leg and solvent is fed at the top of the another leg and it flows counter current to solids through perforation. The rich miscela is withdrawn through a strainer for further treatment and solvent separation. In this case, that is the miscela is withdrawn from. The horizontal basket type extractor, you can see in this figure, that is the prepared sheets are allowed to go or flow through the basket which moves in the direction in this through this belt. Okay. Each basket has a wire mesh or perforated bottom and there are arrangements for feeding the solid and spraying the solvent on the basket. As the loaded basket advances, it is sprayed with full miscela, right, obtained from the bottom compartment. Before making complete turn, the relatively exhausted solid is sprayed with the fresh solvent and the full miscela is finally taken out for further processing, like removal of the oil from the miscela and oil recovery, in other words. Continuous belt type extractor is another common extractor which is used by the industry. In this case, the solids are fed at one end of the extractor, okay, and it is the perforated moving blade. So, in this perforated moving blade at one end the solids are fed and the fresh solvent is fed at the solid discharge end. The liquid drains into a catch basin and is pumped to the top of the adjacent section of the bed. The throughput rate of the extractor can be adjusted by varying the speed of the welt. The height of the bed can be adjusted according to expected rate of the extraction. Difficult percolation is compensated by the bed height. Rotocell extractor, which is basically a immersion type, you can see in this figure. It consists of a number of cells, usually 15 to 18 cells fixed into a central rotor, and each cell has perforated or screen bottom for percolation of the solvent. The solids enter at one end of the cell and the extracting liquid is sprayed on the top of the cell. Below the rotating cell is the circular tank divided into number of compartments to receive the miscela, and the interstage miscela is pumped and sprayed on the next cell in the counter current direction. Now, after having this studied different extractors, that is IL is extracted and then the miscela is obtained. Another important operation is the miscela distillation, that is full miscela contains nearly about 30% IL. Thus, the excess solvent must be removed by distillation, and most manufacturers of the solvent extractors also offer miscela distillation systems. So, the characteristics of a good miscela distillation system include good energy economy, minimal heat damage to the crude oil and its component, minimal solvent losses, efficient removal of the last trace of the solvent from the oil, and good operational safety. The modes of solvent vaporization include flash evaporation, vacuum distillation or steam stripping as the case may be. That is the mainly, that is either steam is allowed or vacuum is used or distillation is used. That is, and another important operation, that is the apart from the distillation, is the miscela filtration, and it is done to ensure the last possible fluid transport defects like clogging of the pumps, pipes, etc., and heat transfer resistances. The miscela must be free, because if in the miscela if there are fine particle solids, etc., they may result into the choking or clogging of the pumps, pipes, etc., or it may reduce the heat transfer efficiency of the material, and therefore, particularly in the evaporation or the rate, that is it will be difficult, or you can process economy may be adversely affected. So, the miscela must be free from solid meal particles with special closed filter presses are used for this purpose. Before it is put to the distillation unit, it is filtered and all the solids are removed from it. Then the meal, as you have seen in the earlier, that is it contains around 30 to 35% solvent. So, it becomes very important operation that these solvents should be recovered from the meal, and this solvent can be recycled and reused, and the meal is used, can be used for different food purposes. So, removal and recovery of the solvent is one of the most crucial operation in oil mill. Okay. And because if the good meal desolventizing step will ensure there is a better recovery of the oil, or almost all full recovery of the oil, because the meal which is obtained, it should have no oil residue, and at the same time the heat treatment given for the meal desolventizing, it should not adversely affect the protein quality, or it should not result into the excessive protein denaturation. It should not disturb its PDI or NSI values. So, this is a one type of modern type of, you can say, there is a desolventizer toasters, which is particularly especially developed, I think, for soybean oil meal, soybean meal desolventization, and this is the here the solvent hexane, which is normally used for extraction of oil. It is removed by this desolventizer, and then finally towards the last stages of the desolventizer, that direct heat is given or steam, superheated steam is given, and the solvent is removed. At the same time the meal is also toasted. So, it consists of a vertical cylindrical stack of compartments or trays. Each compartment is fitted with stirrers, as you can see here. On the racks attached to a central vertical shaft, spent flakes are fed at the top of the desolventizer toaster. The desired amount of heat is supplied to remove the bulk of the solvent from the meal. The pan floor are equipped with adjustable speed rotating valves to permit its downward movement of the material through the pans at a particularly desirable rate. So, in this process this equipment operates and the meal and solvent of meal and of desired quality is obtained. So, other method which can be used, rather a green method, is the supercritical fluid extraction method. We had studied earlier, that is the how the carbon dioxide at in a supercritical stage above a certain temperature and pressure, it behaves as a good solvent and it can be used. Okay. So, in fact, the whatever little problems is there of the oil content, that is the quality of the oil or quality of the meal or the residual oil content in the meal or in the residual solvent content in the meal, etc. All those problems can be removed, or use of the maximum use of the solvent, etc. can be avoided in this process. So, the supercritical fluid extraction, carbon dioxide, supercritical carbon dioxide, its use in the oil milling industry, and also this method can result into the lesser oil losses. It can result into the more or better recovery of the oil with good quality, and therefore, it might result into the lower refining and other costs. So, this becomes a very good economically viable method. So, in this method what is done? A supercritical fluid extraction system we have studied earlier in detail, that is basically it has a extractor, a solvent separator and a recycle pump. So, the extraction is packed bed column, the solute laden supercritical fluid from the extractor is cooled and goes to precipitation chamber, where the pressure is reduced to separate out the solute. Batch extraction is more common because in the continuous feeding of the solid and the removal of the exhausted material is generally difficult. The gaseous carbon dioxide is compressed, cooled and recycled through heat exchanger in order to heat it to required temperature. So, this is the kinetics of soybean oil extraction using ethanol has been explained by a few researchers. They have studied on that expanded soybean mass, that is collates, temperatures studied were 40, 50 and 60 degrees Celsius. The ethanol system was used at, that is with 0 or with 5.98% mass of water, and the result exhibit which you can see in these figures, that is the kinetics of the extraction of free fatty acids or kinetics of the extraction of whole soybean oil, okay, and it increases up to certain level with increase, that is both the soybean oil as well as free fatty acids. It increases initially very fast rate, then it becomes, its rate of extraction becomes slow little bit, and then finally it gets stabilized and it becomes constant, or depending, of course, depending upon the material conditions, process conditions, temperature, pressures and so on. So, the fastest transfer of soluble components to the solvent at the beginning of the process, I told you, is followed by a decrease in the transfer rate unit, and then finally it becomes constant corresponding to the maximum yield of extraction. The values of soybean oil diffusibility coefficient increased with increasing temperature in both solvents, and the values of soybean oil diffusibility coefficient increased with increasing temperature in both solvents and decrease with increases in the water level in the solvent for the same extraction temperature. The kinetics of extraction of free fatty acids is like similar to that for the oil, and the value of diffusibility coefficient for the soybean oil, as you can see in this figure, increased with increasing temperature as well as with the decreasing water level of solvent. Now, this final here, before ending the lecture, I will just like to give you, this is a commercial plant extraction facility starting from the handling of the material whole seed until we get that oil and meal. So, you can see in this process flow chart and the diagram that is this unit is basically the crop handling unit, where this seed is coming, it is basically for soybean oil extraction and meal processing, but it can be used for any other like even groundnut and all those things with little variations in the one or two equipment or with little variations in the process parameter. So, obviously, in this material handling unit there are conveyor belts, silos, drum dryers, cooker or cooler, conditioner, grinder, aspirators, etc. Means that is in this section, that is the soybeans, dehulled soybeans are obtained. Then even the hulls are grinded or aspirated, and then we get crushed, that is section. So, this section, that is the suitable, as we have seen in the earlier class also, the pre-treatment, in the pre-treatment, that is the cooking and conditioning and crushing are required for the flaking, all those things is done. So, and after that, this section is the extraction section, where these they are the prepared meals are fed to the extractors, all right, and before there is the extraction processing. If this is a press mill, that press it is fed, or in the solvent extraction before passing to the solvent extraction, the flake or pelletizing units are flaking rolls it is passed, and these porous flakes are passed to the solvent extraction. From the solvent extraction you get that oil and miscela, then it goes to the miscela desolventizing or oil recovery and meal desolventizing, and finally that is meal, oil and meal and oil both are obtained. This meal, it can be further sent to the for food preparations, or the oil which is obtained. In fact, most of the solvent extraction plant, they have degumming, because along with, depending upon the processes, that is along with oils, certain phospholipids, gums, etc. also get extracted. So, they are separated right at the extraction plant itself using water degumming. So, most of the extraction plant, they are equipped with this facility for removal of gums from the oil through water degumming process. So, of course, that is a step of the, after that from here the oil is passed through the refining, where it is subjected to various other treatment like acid degumming, chemical refining or physical refining, deodorization, bleaching, etc. And finally, the any type of impurities which might be present into the oil, they are completely removed during the refining step, and it is a purely triglyceride is obtained. That is the objective of refining. Of course, details of the refining process and its steps, etc., how it is carried out, we will take up in the next class. This, I thank you all for your kind hearing.